Today we're going to be talking about the law of sines and law of cosines. So to quickly refresh your memory, take a moment and pause the video just to write this down. The law of sines is A over sine A equals B over sine B equals C over sine C. Or you can flip it and get the other one. This sine A over A, sine B over B, sine C over C. But I'm just going to box this for you. That's the law of sines, so you just want to make sure you recall that and write that down for your notes. Now that you've written it down, let's use it. So notice how we're going to use it for a side angle triangle, meaning there are two angles given. So I'm going to draw a generic triangle here for us. I'll label it generically A, B, and C. Remember that little a is across from big A, little b is across from big B, and little c is across from big C, meaning these always correspond like that. And that's because if you imagine, like, if you were to make this angle bigger, it would affect this leg. And you can apply that for all the legs. So let's get right to it. Let's fill it in. A is 46 degrees right there. C is 63. And then we have C is 56. So I'll just make that right there. Our goal is to figure out everything. And your book is going to say round sides to the nearest tenth. For us, we're going to round sides to the nearest hundredth, just to be a little more accurate. And then angles, we're going to round to tenths. But you'll see that in the work. So the first thing we want to do is let's locate that last angle right there. So we can just add 63 and 46, that's 109. So subtract that from 180, that should be 71 degrees. So again, I'm just doing 63 plus 46. That would be 109. 180 minus 109, that's 71. That's how I got that angle. And now we're going to figure out A or B. Now the way we're going to do that is we have to do this. Put a big star. We have to identify the pair. And what I mean by pair is an angle and its respective side. So for example, in this problem, the pair is right there. Because notice how that's the only one where we have both the angle and the respective side given. So that's where we're going to start. We're going to write 56 over sine 63. That's going to equal, let's solve for A or B, doesn't really matter. That's A over sine 46. Let's solve for A. We're going to multiply both sides by sine 46. So A is going to equal 56 sine 46 all over sine 63. Now to do this, we're going to need our calculator, degrees. So make sure you set this to degrees. We've been in radians from our last class. And all we're going to do is type in the expression exactly as it was. Hit enter. There it is, 45.21. So we come back here. This is 45.21. So I'm going to fill that in. A is 45.21. Now I'll do the same thing for the next leg. You can just do 56 over sine 63. That should equal B over sine 71. Multiply by sine 71. So B is going to equal 56 sine 71 all over sine 63. 59.43. So we'll just fill that in. 59.43, and there's our complete triangle right there. And I'll just highlight the things we found. Okay, next example. Notice how we have a side angle side triangle here. It says solving a side angle side triangle. So if I were just to sketch this generically like that, I'll label it again, A, B, C. This is 60, B is 20, C is 30. I want you to notice very quickly that we cannot use a law of sines because there is no pair. So again, there's no pair, which means we cannot use the law of sines. It's just not going to work. So that's how we have the law of cosines. So take a minute and just write down the law of cosines right here. Notice how there are three versions. This is the main version right here. This is the one like every book has. The other versions are just there because the letters are arbitrary. Letters are arbitrary, meaning you can assign them as you want as long as you follow the pattern. So it's not like you always have to use c squared equals. It can be a squared or b squared as long as you follow the respective pattern. So for example, on this one, notice how we're going to use this one right here because we're given our side angle side here, and we want to find what this a would be. So let's write it out. A squared is equal to 20 squared plus 30 squared minus 2, 20 times 30. I'm going to move this. Cosine of 60. So a is the root of all that. So you type that in your calculator, and then you are going to get 26.46. So I'll fill that in right here. 26.46. Now once we have that, what we're going to do is find the other angles. And notice how now by finding A, we do have a pair right there. That's a pair, which means we can do the law of sines. Now the only thing you want to be careful of is that if you do this method, you want to use a law of sines to find the acute angle. So let me show you what that means. I'm going to move this work right here. Again, we're going to use the law of sines to find the acute angle. Now the reason for that is because if you think back to sine inverse, the range of sine inverse x, that's going to be negative 90 to positive 90, which means if you use that in your calculator won't give you an obtuse angle, which means we kind of want to avoid using it to find an angle that could be obtuse. So if you look at this triangle, we got to think about what angle has to be acute. And if you think about that, it has to be this one, B. And that's because 20 is the smallest leg. So therefore, there must be an acute angle that pairs with it. So that's what we're going to do. We're going to write sine B over 20 should equal our pair, sine 60 over 26.46. Let's solve. So sine B should equal 20 sine 60 over 26.46. Let's inverse this thing. You plug in your calculator and you're going to get angle B is 40.9. So let's just fill that in, and now we're pretty much done. This is 40.9, which means the last angle has to be 79.1. So notice how they're all acute, so it wouldn't matter in this case, but it would matter if one of the angles were obtuse. So that's why you really want to highlight this part. Use law of sines to find the acute angle. Last example, side, side, side triangle. So again, I'll draw it generically. Here's A, B, and C. A is 6, B is 9, C is 4. So clearly this is not drawn to scale. That's okay. We're going to use a law of cosines here because there's obviously no pair. But what we're going to do is use the law of cosines to find the largest angle. Because if you recall, the law of cosines, if we're going to use cosine inverse, the range is 0 to 180, which means your calculator can find any angle in a triangle, which is very convenient. So that way, when we get the law of sine, just don't worry. We know the rest will be acute. So again, we're going to use law of cosines to find the largest angle. To do that, look at the largest leg. That must be 9. That must correspond to the largest angle, which would be b. That's what we're going to do. So we're going to use this version. B squared equals a squared plus c squared minus 2ac cosine b. So 9 squared should equal 6 squared plus 4 squared minus 2 times 6 times 4 cosine b. Let's do some algebra. Cosine b should equal 9 squared minus 6 squared minus 4 squared divided by negative 2 times 6 times 4. I'm going to cosine inverse this, and then we're going to get b is 127.2 in your calculator. So it was obtuse, which is good. That means we found the biggest angle. All our work is checking out. From there, we're just going to use law of sines now. And it won't matter which one we do. I'll just pick a. I'm going to write sine a over 6 should equal. And if you're confused, notice how we have a pair now. There's our pair. That's going to be sine 127.2 over 9. So sine of a should equal 6. Sine 127.2 over 9. Let's sine inverse everything. And you're going to get a is equal to 32.1. So we'll fill that in, then do some basic arithmetic, and you're going to get 20.7 for the last angle.